Hello everyone, in this video I am going to explain the problem that is maximum product subarray, and I am also going to explain the solution of it. The problem statement is that we are given an integer array and we need to find the subarray that has the largest product, and we simply need to return that product. Let's consider this is the array that are given to us, and we need to return we actually need to return the product that is the largest subarray. So if we consider the subarrays of this array, this could be 2, this could be 2, this could be 3, this could be minus 2, this could be 4, this could be this 2 and 3, this could be 2 3 minus 2, and so on and so on. So if we can see that we can simply say that 2 and 3 would produce the largest product, that is 6. All the other subarrays would produce a sum that is either negative or smaller than the 6. So 6 would be the answer here, and this is the subarray that would have this maximum product. So if let's quickly jump to the solution of this problem. So there are many ways to solve this problem. One of them is a brute force approach, in that we will find all the subarrays of each element one by one, and then we will find the maximum from them. So that approach is brute force approach, but its time complexity is much higher, so we won't be going with this. Instead we will be going with another approach that is much better. So before explaining the solution of this, let's have some observations to understand the problem. So let's say if we are given this array, and for just for sake of example, consider that all the numbers are in the array positive. In that case, all the entire subarray would be the solution. If there are even number of elements, even number of negative elements, then entire array would be the solution of it. In case the number of negatives is odd, then we simply need to exclude one of the negative number, and that would produce a subarray that has the maximum product. So this is the three things that we need to keep in mind. And there is also fourth constraint that we need to keep in mind for this solution, is that if the 0 comes to the picture, so we cannot include the 0 in subarray, because it would produce 0. It won't matter whatever elements are there in the subarray. If there is 0, the 0 would be the product of that subarray. So we would need to take care of these observations, these constraints, before writing the solution. Okay, so the solution that works here is that we need to find for each element in the array, for each element of the array, we need to find the product of prefix elements and the product of suffix elements. So let me explain how that solution works. So consider, let's say I need to exclude minus 1 from the subarray. So there is a possibility that either this suffix of minus 1 would be the answer, or this would be the answer. Or if, let's say, I would like to exclude minus 10, so this would be the answer. This subarray is the suffix of minus 10, and this subarray would be the this would be the suffix, and this would be the prefix. This would be the prefix of minus 10, and this would be the suffix of minus 10. The same goes for minus 4. 23 would be the suffix, and entire this array would be the prefix. And for the positive numbers, uh, for let's say for 2, the suffix would be 0, and the prefix would be the entire this array. For 3, 2 would be the prefix, and this would be the suffix. So why this solution? So let's understand how this solution works and why this solution works. So if there are all the positive numbers in the array, then the prefix suffix kind of won't work, because we would if in each prefix we would be excluding one of the elements. So we basically here use the neat trick in which the prefix could be or suffix could be the entire array. So the entire array, we would be considering the prefix, we would be considering the complete array as a prefix and suffix as well. So this would solve our problem of constraint. It would solve our constraint that there are all positive numbers in the array, or there are even number of negatives in the array. So the third thing that we need to cover, there are odd numbers of negatives. So for that we need to find all the prefix of each element. It could be this, it could be this, and we need to find the maximum of these prefix and suffixes, considering that prefix and suffix includes the entire array as well. So this would be the this would be taken care of, but there is another case to cover, that is the case of 0. So if let's say there is a 0 in between in this array, so the 0 would make the prefix of 8 as 0. However, it won't affect any suffix of it, but it will make the prefix product as 0. So for handling the 0, what we would do, we will simply initialize prefix with 1, so that the further multiplication can be taken care of. Okay, so that's how all the cases would be taken care of. So for example, let's say what we will do, we will initialize prefix and suffix. We will be iterating over the array, and we will try to find the prefix. So prefix here basically becomes the multiplication of elements like this. So in first iteration, the prefix would be initialized to 1, then the prefix of 3 will be calculated, which would be 2 here, and then prefix of minus 1 would be calculated, which would be 6, then the prefix of 0 would be calculated, which would be minus 6, and then the prefix of 8 would be calculated, that would be 0. So in this way we will keep multiplying the numbers. When we have encountered a 0, we will reset the prefix to 1, and we will find the prefix as 8 for minus 10. Given we have virtually divided the array in two parts, if there are 0 in the array. So virtually consider that this array has been divided into two parts, 2, 3, minus 1, and 8, minus 10, 1, minus 4, and 23. So we would be starting with this as a fresh array. So for 8, the prefix would be 0, but for minus 10, the prefix would be 8. For 1, the prefix would be minus 80. For minus 4, the prefix would be again minus 80, and so on and so on. So this is how we will be calculating the prefix, and in the similar manner we will be calculating the suffix. The only difference is that in the case of suffix we will be starting with the last element. So we will do the same thing. We will initialize suffix with 1. We will find the suffix of minus 4 as 23. We will find the suffix of 1 as 23 into minus 4, and so on and so on. So important here is to note that out of these calculated prefix and suffixes, there would be an prefix or suffix that has the maximum product. So that prefix would be our answer. Also important thing here to note that we need no need to find the prefix of an element and suffix of suffix of an element at the same time. Okay, so so I have already implemented the solution of it, so I just simply write down the solution here and just explain the solution to you. So this is the solution that we are going with. We find the length of array, we initialize the maximum as integer minimum value. For simplicity, I have uh, divided the calculation of prefix and suffix into two different loops. Actually this can be combined into only one single loop, but for the simplicity I have used two loops. So we are iterating over the nums array, and in case our prefix is 0, we are initializing the prefix 1, that's handling the case of 0 element, and prefix is simply the prefix into the ith or jth element of the array, and max would be storing the maximum of prefix and suffix here. So this is simply math dot maximum product and prefix. Similarly, we are finding the suffix, but instead we are iterating from the other side. So this would be like this: integer I is equal to n minus 1, I less than I greater than equal to 0, I minus minus, and the number would be simply, if suffix is 0, suffix is initialized to 1, the suffix here would be the number itself. So number would be the numbers ith element. So nums, yes, ith element would be this. So this is the case. So this let's run the solution. So it works. So that was the solution of it. Thank you everyone.